Hello everyone, welcome to Chirag's PostgreSQL debate tutorial. In this video, we are going to learn how to deep tuning of PostgreSQL 17 on Ubuntu 24.04 LTS. So here we'll just look after the installation. The tuning is the important part of the any databases. So we'll just tune the database to for the fast access and improvement of the performance. So now I'm going to with the server. So server IP is 192.168.224.135. For the deep tuning with the Postgres 17 on the Ubuntu 24.0 LTS, the focus will be on optimizing setting for the high performance and reliability based on your specific system hardware resources, workload and query patterns. Deep tuning involves adjustment parameter related to memory, disk I/O, input output, caching and query execution. Let's explore advanced tuning option for PostgreSQL. So first step is memory tuning. So let me access the system. So I'm running with the VMware workstation. This is my server. So running with the 24.04 LTS. So opening this one, SSH, DPT my user 192.168.224.135. So do SU. First check my database is running or not. So systemctl status PostgreSQL. So there is a Postgres is working and this is running successfully. So let me log in and test sudo su sudo minus u postgres postgres and psql. So PostgreSQL we are able to log in. Here we can list of the databases. So these are the list of the databases we have. So we do that. So now, first thing is memory setting for the critical for the PostgreSQL performance, especially for the high load environment. So shared buffer. Shared buffer is the amount of the memory dedicated to caching data for the PostgreSQL. A good sharing point is the setting of the 25% of your system RAM. Whatever the RAM you are using, just like 4 GB, 8 GB. If you are using 8 GB, then 2 GB you can give to the shared buffer. For example, shared buffer 4 GB means we have a RAM of 16 GB. Here just 4 GB we have a RAM of 16 GB, then we'll give the 25% of that. So let me open that. Sudo sudo nano where lab postgres 17 and main etc postgres 617 main, and there is a configuration file postgres.conf. So we'll open this one. First we'll go for the shared buffer. So Windows Control W, shared buffer. So shared buffer I'm giving 128 MB. As per your RAM, I have 1 GB, approx 1 GB. So I am giving the 128 MB. Next, Workman. Workman specifies the amount of memory allocated for the internal source operation and hash table before using the temporary disk file. So this setting affects complex queries. Example, those with the order by, distinct, join operation. If you expect the complex query, set the based on the your available RAM or concurrent connections. Here I am giving the 16 MB. As per your requirement, you can give more. This is a 4 MB. Minimum you can give for 64 KB. So this is also done. You can increase the value based on your workload. Maintenance Workman. This will be control of the memory available in the maintenance operations such as the vacuum, create index, alter table. This system will the larger data sets. Increasing this can speed up task. This task. So maintenance work memory. I am giving the 1 GB. So I'm giving the 64 MB. Minimum is 64 KB. So you can give as per your requirement. Effect cache size. The effective cache size setting is eliminates how much of the operating systems file and system cache PostgreSQL can use. This helps the query planner estimate whether a particular index will be fit into the memory. Typically, you can set this to around 50 to 70% of your total system memory. So here is an example. If you have the 16 GB operand, 75 is equal to 12 GB, you can give to the effective cache size. 75% means I'm using the 1 GB, I think, in RAM. So you can give the, mm, so I'm giving 75%. So 1080, 7, how much it will be? 1024 percentage. Okay. 1024 into 75, 256 into 3. So 768 I'm giving here. 768 MB. Next is disk IO set tuning. PostgreSQL high dependent on the disk IO. Optimizing how PostgreSQL reads and writes on the disk on the crucial for performance. So checkout setting. So checkout points a moment when the all data is flushed to the disk. Optimizing this reduce disk IO pressure during the peak time. So there is a checkout segment. Control the log segment between the checkpoints. Checkout timeout. Increase the time between the checkpoints. And checkout completion time. Control how the aggressively PostgreSQL write data buffers to disk between the checkpoints. So checkpoint timeout I am giving here 15 minutes. So default is 5 minutes. 15 minutes can be a good starting. Search this one. Initially I'm giving the 5 minutes. You can change to 15 minutes. Next, target is 0.9, checkpoint warning is 30 seconds, and max wall size is 2 GB. So this one 0.9, warning is 30 seconds, max wall size I am giving it 1 GB. As per your requirement, define the max size of the wall write ahead log. So I am giving the 1 GB for the write ahead log size. And next is wall setting. Wall setting is the write ahead log setting. So write ahead log setting control how the Postgres writes the transaction to the disk. So there is a wall buffer and wall writer delay is there. So increase the there is a wall buffer. Define the amount of the shared memory for the wall and control how often wall is flashed to disk. Increase this slightly can reduce your IO without impacting durability. So I am giving this one is 16 MB or -1 if you are giving then this will be based on the your shared buffer 16 MB. Next is wall writer delay. Okay. So there is a 500 millisecond. I'm giving the 200 increase from the default 200 for the better performance. So you can increase 500. Random page cost. So random page cost tell you the Postgres how the expensive is the read the page randomly from the disk. And if you have a fast SSD, you can lower this to improve the index. So this one is 1.1. So 0.4 is there. I'm giving this one 1.1. Sequence page cost. So sequence page cost is the reading the page sequentially. So this one I'm giving the 1.0. Next, connection tuning. So max connection based on the default max connection is 100. Here they are giving the 200. So increase as per your requirement. So max is 100. If you want, then you can change to 200. Next is auto vacuum training. This is the important part. So auto vacuum process automatically reclaims storage for the cleaning up to the dead rows. However, its default configuration can lead the poor performance if not done. So auto vacuum setting is there. So there is auto vacuum setting. Cost delay is 10 seconds. Lower this to decrease the auto vacuum impact. So there is a written with the description. Okay. So you give the 10 second, I'm giving the 2 second for now. 3 for the analyze factor. Always keep the backup of your postgres.config file before doing this. And query planner training. Enable JIT completion, just in time completion of the faster query execution. Enabling this improve the performance for the complex query. So JIT I'm going to so JIT I'm going to on this one. Then come to the parallel query. So PostgreSQL can run the query in the parallel across the multiple CPU where you can speed up the large scheme of join, tuning the number of workers in the critical for improving the query performance. So how many based on your available CPU, just remember that. So here I'm giving the two and we can run the worker process, max worker process, max parallel worker. So worker process is 8, max worker process is parallel worker is 8. So there are number of processes that can be used for the parallel operations. Okay. Next, login and monitoring. So here the log for the minimum duration is 1000. So -1 means disable and give some amount and the log checkpoints is on. Log weights should be on and log temp files. So this will be 0. Okay. So up to this run. Next is enable the state collection. So track IO timing is on, input output timing, then track activity, query size, change required the restart. So we'll restart this one, and 1024 or 1 GB. Don't have lost lot of memory. So I'm giving the 1024 1 GB approx. Track function is all. Next is the kernel and OS level tuning. So adjust the memory and setting the Postgres on the OS level. So we have to add into the last. So we can add this one in last. File description. So increase the number of descriptors allow the Postgres. You can configure into the editing this file. So security limits, I'll just increase on that. So here we'll add this too. Again, I'm opening the Postgres, and here we'll check this one, change. Now additional consideration. So there is a partitioning is there. If for the large server, consider using table partitioning or split it into the smaller or more manageable pieces. Index a regular review the index usage and do that one. And database maintenance schedule for the vacuum and reindex operation for the optimizing performance. Now restart the Postgres to apply the changes. So we are going to restart. So system is restarted successfully. So tuning PostgreSQL 17 for the deep performance optimizing involved careful adjustment for the memory, IO, input output, query execution, and connection string. These changes should be tested based on the your actual workload to ensure they are providing the desired improvement. Keep monitoring query performance and system resources to ensure that PostgreSQL remains well optimized for your environment. Let me know if you need any further details or guidance. For any doubts and query, please write on the YouTube video comment section. Follow the process shown in the video. Please subscribe and like for the more videos. So thank you for watching. Hope this will help.